Hello, I am Pablo Puello and I'm going to present CineMPC, Controlling Camera Intrinsics and Extrinsics for Autonomous Cinematography. This work was done in collaboration with Eduardo Montijano and Ana Cris Murillo from Universidad de Zaragoza and Max Weiger from Stanford University. First, I want to talk about the motivation that brought us to develop CineMPC. Drones are more and more used in the cinematographic industry due to its ability to record scenes from points that are not accessible for regular cameras. In the robotics community, there is a growing interest in developing control and planning strategies for controlling cinematographic drones autonomously. Existing solutions just control the position and orientation of the drone and the camera, namely the extrinsics of the drone. CineMPC, however, includes the intrinsics of the camera into the control problem, that is the focal length, the focus distance, and the aperture. This enables to control a wider variety of cinematographic effects, leading to a visually richer recording. This video shows the qualitative difference between recording the same scene, including the intrinsics into the control problem, and not including them. But what is the effect of the intrinsics on the final image? First, controlling the aperture allows us to control the depth of field, that is the part of the scene that is shown in focus or defocused. The focal length enables the control of the optical zoom and the image composition. And controlling the focus distance allows to set the point of the scene that appears in focus in the image. The final objective of CineMPC is to use a drone that is holding a cinematographic camera to autonomously record one or more targets that are present in a scene. The user introduces a set of instructions to record targets with a determined depth of field, image composition, and relative recording pose, and CineMPC solves an optimization problem using a model predictive control framework to control the drone and the camera, producing autonomous cinematographic filming. Without entering into details of the optimization problem, the cost function of CineMPC is an addition of three constants, one for each cinematographic effect that we aim to control. Next, we describe them in detail. The depth of field is the part of the scene that appears in the image acceptably in focus. It is delimited by the near and far distances, as shown in the diagram. The cost term of this effect uses the equations that are displayed to control the focus of the image autonomously. At the end, these equations depend on the focal length, the focus distance, and the aperture. That is, the intrinsic parameters of the camera. CineMPC is the first robotic system that considers them inside the control loop. The image composition term aims to place the targets in particular regions of the image, while satisfying some cinematographic composition rules. One of the most known is the rule of thirds, where the frame is divided in thirds that the targets should match. The positions of the target on the image are determined by these equations that depends on the focal length and the relative pose between the drone and the target, that is, the extrinsic and intrinsic parameters of the camera. CineMPC includes the control of the intrinsics as part of this problem. The relative position and rotation between the drone and the target also determines the kind of shot. This cost term optimizes the relative distance and rotation between the camera and the target, just depending on the extrinsic parameters of the drone. This experiment shows how the three cost terms are used to achieve a cinematographic footage, where the depth of field, the position of the targets in the image, and the relative pose are controlled in real time, following the instructions of the user. The system receives different instructions in real time and adapts the trajectory of the intrinsics and extrinsics to satisfy the new instructions. I hope you like CineMPC and to see all of you in the poster session to talk about it in more detail. Thank you so much for listening.